They said it couldn't be done. A train with no wheels, a locomotive that refuels itself rolling downhill, a machine that crosses paths with another at 896 kilometers an hour, nearly the speed of sound, and doesn't tear itself apart. The engineers who built these weren't just impressed, they were rattled, because these 10 locomotives didn't break a record and go home. They broke the rules physics teachers swore were unbreakable. Buckle up, this one gets ridiculous fast. Number 10. Stadler FLIRT Akku. Let's start with a machine that shattered a belief the entire rail industry held to be true, that batteries could never carry a passenger train very far. Enter the Stadler FLIRT Akku, a battery-electric multiple unit built by the Swiss manufacturer Stadler. On paper, it's a regional commuter train, the kind that shuttles people between small towns. Nothing about its appearance screams record breaker, and that's exactly why what it did stunned everyone. Stadler's own engineers designed and calculated the vehicle for an operational range of about 80 kilometers on battery power alone, enough to cover the unelectrified gaps between overhead wire sections. That was the promise. That was the number they guaranteed to customers. Then, in December 2021, they decided to find out how far it could really go. They ran the 3-car train from Berlin to Warnemünde, not in ideal conditions, but in the dead of winter, with temperatures hovering right around freezing, the worst possible environment for battery performance. Cold weather is the enemy of every battery on Earth. The result? The FLIRT Akku traveled exactly 224 kilometers in battery-only mode, nearly 3 times its guaranteed range, without pulling a single watt from an overhead line. Independent inspectors from TÜV Nord rode along to verify every meter of it. That run earned an official Guinness World Record for the longest journey ever completed by a battery-powered passenger train in pure battery mode. Why did this shock engineers? Because it proved that thousands of kilometers of diesel-only branch lines across Europe, routes everyone assumed were too long to ever electrify with batteries, could suddenly go zero emission. A commuter train quietly rewrote what was possible. Number 9. Wabtec FLXdrive. If the FLIRT Akku surprised people, this next machine flat-out defied physics. At least the physics everyone assumed applied to freight. Heavy-haul freight is the brutal end of railroading. We're talking trains that weigh tens of thousands of tons, dragging iron ore across entire continents. For over a century, the assumption was simple. Only massive diesel engines could produce that kind of grunt. Batteries? Laughable. Then Wabtec, the American giant born from the old Westinghouse and GE transportation lines, built the FLXdrive and unveiled the first full production model in October 2023 alongside Australian mining company Roy Hill. Here's what inside, and it's genuinely staggering. The FLXdrive packs 72 lithium-ion modular battery packs, containing a total of 36,288 individual cells, giving it an energy capacity of 7 megawatt-hours. To put that in perspective, a single megawatt-hour could power an average American home for over a month. This one locomotive carries 7 of them. But the truly clever part is how it works. On Roy Hill's 214-mile iron ore railway, in the scorching Pilbara region of Western Australia, where temperatures hit 55 degrees Celsius, the loaded trains run downhill toward the port. As they descend, the FLXdrive uses regenerative braking to capture the energy that would normally be wasted as heat, recharging its own batteries. Then it uses that harvested energy to help haul the empty train back up to the mine. It literally refuels itself by going downhill. The earlier 2.4 megawatt-hour prototype had already run 13,000 miles on BNSF Railway in California with 0 failures. The production model nearly tripled that capacity. Engineers were shocked, not because a battery locomotive existed, but because one could survive the single most demanding job in all of railroading in one of the harshest climates on the planet, and cut a train's fuel use and emissions by double-digit percentages while doing it. Number 8. Stadler Flirt H2. Stadler makes this list twice, and for good reason. Because their hydrogen train did something almost no one believed a hydrogen vehicle of any kind could do. The Flirt H2 is a hydrogen fuel cell passenger train built for the San Bernardino County Transportation Authority in California. It stores hydrogen in 350 bar Type 4 composite pressure vessels and converts that hydrogen into electricity through fuel cells, with water vapor as the only exhaust. In March 2024, at the EMSCO Test Center in Pueblo, Colorado, Stadler's engineers set out to see how far it could run on a single fill of hydrogen. No refueling, no recharging. They drove it in shifts around the clock through the night and into the next day. When they finally stopped, the odometer read 2,803 kilometers, that's 1,741.7 miles, traveled continuously for more than 46 hours on one tank. That earned a Guinness World Record for the longest distance ever traveled by a hydrogen fuel cell passenger train without refueling or recharging. Think about that number. That's like driving from Los Angeles to Chicago without stopping for fuel in a train. Range anxiety is the #1 criticism hurled at every clean energy vehicle, and the Flirt H2 didn't just answer it, it obliterated it. For engineers, this was the proof that hydrogen isn't just a lab curiosity for short shuttle routes. It's a genuine long-distance replacement for diesel on the thousands of kilometers of track around the world that will never get overhead electric wires. Number 7. Alstom Coradia, iLint. Before the Flirt 2 chased distance records, one train had to be brave enough to go first. That train was the Alstom Coradia iLint, and it changed the entire conversation about clean rail. Unveiled by the French manufacturer Alstom at the InnoTrans trade fair in Berlin in 2016, the iLint holds a title no other train can ever take away. It was the world's first hydrogen fuel cell passenger train. It's built on the proven body of Alstom's diesel-powered Coradia Lint, but with the diesel engine ripped out and replaced entirely by hydrogen fuel cells. In 2018, it entered commercial service in Germany, carrying paying passengers. Then in August 2022, in Bremerwörde in Lower Saxony, 14 of these trains took over the world's first fully hydrogen-operated passenger route, completely replacing the diesel fleet on that line. The performance matches the old diesel units it replaced, a range of up to 1,000 kilometers on a tank, a top speed around 140 kilometers per hour, and space for up to around 300 passengers. But instead of belching diesel fumes and roaring through stations, the iLint emits nothing but steam and condensed water, and it runs remarkably quietly. In a September 2022 test, one even managed 1,175 kilometers on a single tank of hydrogen. The iLint has since racked up millions of kilometers in service across multiple European countries. And in 2023, it became the first hydrogen train to carry ticketed passengers anywhere in the Americas, running a demonstration through Quebec's stunning Charlevoix region. Why did it shock engineers? Because for decades, the only realistic way to eliminate diesel was expensive overhead electrification. The iLint proved there was a third path, and it worked in daily passenger service, not just on a test track. Number 6. CR400 Fuxing. Now we shift from clean energy to raw, everyday speed, and to a train that turned China from a rail importer into a rail superpower almost overnight. The CR400 Fuxing, the name means rejuvenation, is China's standardized high-speed electric multiple unit, and its headline achievement isn't a one-off record on a closed test track. It's this: the CR400 operates in scheduled commercial service at 350 kilometers per hour, making it the fastest scheduled passenger train service in the world on conventional rails, running that speed for ordinary ticket holders every single day. Since 2017, these trains have blazed along the Beijing-Shanghai line, a distance of over 1,300 kilometers, cruising at 350 kilometers per hour, with passengers sipping tea inside, so smoothly that the famous demonstration of standing a coin on edge on the windowsill actually works. What shocked international engineers wasn't only the speed. The French and Japanese had reached similar test speeds years earlier. It was that the CR400 was developed as a fully Chinese-designed and Chinese-standardized platform, with the vast majority of its key systems built domestically. China had gone from licensing foreign technology to exporting its own in barely more than a decade. The Fuxing family is enormous and endlessly adaptable, versions built to slice through the freezing winters of the Northeast. versions lengthened to 16 cars carrying over 1,000 passengers, and versions that automatically drive themselves between stations. It became the backbone of the largest high-speed rail network ever built, a network now stretching across tens of thousands of kilometers. The CR400 is proof that sometimes the most shocking engineering feat isn't a single record. It's scaling world-beating technology to an entire nation. Number 5. CR450 Fuxing. If the CR400 was the statement, the CR450 is the answer to the question, how far can steel wheels on steel rails actually go? And the answer redefined the ceiling. Unveiled as a prototype in Beijing in November 2024, the CR450 is engineered for a blistering top test speed of 450 km per hour, with a planned commercial operating speed of 400 km per hour, which would make it, by a wide margin, the fastest scheduled train service on the planet. Then, in October 2025, during pre-service qualification trials on the Shanghai to Chengdu high-speed line, the prototype hit 453 km per hour. But that wasn't even the most jaw-dropping figure. During testing, two CR450 trains passing each other in opposite directions registered a relative passing speed of 896 km per hour. Let that sink in. Two trains crossing paths with a combined closing speed approaching the speed of sound, and the air pressure wave that creates is violent enough to rattle windows and shove the train sideways. Managing that safely is an engineering nightmare. How did they tame it? The nose cone was stretched from the 12.5 meters used on 350 km per hour trains to a sleeker 15 meters, cutting drag. Overall aerodynamic resistance was slashed by 22%. The train carries more than 4,000 onboard sensors, monitoring critical systems in real time, and despite going 100 km per hour faster than the CR400, engineers kept the braking distance and energy efficiency within the same standards. The CR450 can rocket from a standstill to 350 km per hour in just 4 minutes and 40 seconds, a full 100 seconds faster than its predecessor. Before it can carry passengers, it must accumulate 600,000 kilometers of successful trial running. But the point is already made. Engineers were shocked because everyone assumed conventional rail had hit its practical speed limit. The CR450 kicked that limit down the road. Number 4. Shanghai Transrapid. Now we leave wheels behind entirely, because everything from here on floats. For decades, magnetic levitation was the flying car of railways. Forever 10 years away, forever a lab experiment. Then, on the last day of 2002, a German-built machine started running in China and turned science fiction into a daily commute. The Shanghai Transrapid, also called the Shanghai Maglev, was built using German Transrapid technology from a consortium of Siemens and ThyssenKrupp. It became the world's first commercially operated high-speed maglev line, connecting Shanghai Pudong International Airport to Longyang Road Station on the edge of the city. The technology is almost eerie to witness. There are no wheels touching the track. Powerful electromagnets lift the train and propel it forward, with no rolling friction at all. From a standing start, it takes just a few minutes to reach a top operational speed of 431 km per hour, covering the roughly 30-kilometer route in about 8 minutes, a trip that can take an hour by taxi and traffic. At 431 km per hour, it held the Guinness World Record as the fastest maglev in regular public service, and it remained the fastest scheduled commercial train on Earth from its 2004 opening for many years. During a test run in November 2003, one even touched 501 km per hour. In recent years, the everyday top speed has often been reduced to conserve energy, but the record and the achievement stand. What shocked engineers was simple. Maglev finally left the laboratory. Skeptics had spent decades insisting a commercial maglev would be too expensive, too fragile, too impractical to ever run reliably. Shanghai's has been floating passengers to the airport, day in and day out, for over 2 decades. Number 3. CRRC 600. The Shanghai Transrapid was imported German technology. This next machine is China's declaration that it intends to own the future of levitation. In July 2021, at the CRRC Qingdao Xifang factory in Qingdao, China, rolled out the CRRC 600, a high-speed maglev transportation system engineered for a top speed of 600 kilometers per hour. At its unveiling, CRRC billed it as the fastest ground transportation vehicle in the world by design. 600 kilometers per hour is a genuinely absurd number for a ground vehicle that's nearly half the speed of sound. CRRC's deputy chief engineer laid out the vision precisely. On a Beijing to Shanghai journey of over 1,200 kilometers, counting the time you actually spend getting to airports and waiting around, a plane takes about 4.5 hours and conventional high-speed rail about 5.5. This maglev, they claimed, could do it in roughly 3.5, beating the airplane door to door. The system is built on Transrapid electromagnetic suspension technology, licensed from Germany, but developed by CRRC with its own engineering. It floats on a magnetic cushion, eliminating rolling friction, so the main force fighting it is simply the air. Now, an honest note, because accuracy matters, the CRRC 600 has been shown as a complete, full-scale train set, but it has not yet run at 600 kilometers per hour in service. Reaching that speed requires an entirely new, dedicated guideway. Maglev can't use ordinary tracks, and building those lines is astronomically expensive, which has delayed commercial deployment. But the machine itself and the complete engineering system behind it is very real, and it put the entire rail world on notice. Engineers were shocked because China demonstrated it had mastered the full 600 km per hour maglev technology stack, closing a gap that only Japan and Germany had ever seriously approached. Number 2. TGV V150. Before we reach the fastest rail vehicle ever built, we have to honor the fastest one that still touches the rails, because what France did in 2007 remains, to this day, an untouchable world record. The machine was called the V150, and it was no ordinary train. It was a specially configured TGV, stripped down and tuned to the absolute edge of what wheel-on-rail technology could survive. The setup: 2 power cars sandwiching just 3 double-decker cars, lightened to only 265 tons. The wheels were larger than standard to cover more ground per rotation, and the power output was cranked up to a monstrous 19.6 megawatts, around 25,000 horsepower, more than double a normal TGV. On April 3rd, 2007, on a brand new, not yet opened section of the LGV Est high-speed line between Paris and Strasbourg, driver Eric Pichak eased the V150 up the speed curve, while dozens of technicians monitored every system. At kilometer point 191, where the track profile was most favorable, the train peaked at 574.8 kilometers per hour, 357.2 miles per hour. At that velocity, the wheels were spinning at nearly 3,200 RPM, and the train was drawing around 19 megawatts, enough to power a small town. The overhead wire had to be specially tensioned so the current pickup wouldn't literally lose contact at those speeds. That 574.8 kilometers per hour figure set the world speed record for any wheeled train on conventional steel rails, and astonishingly, it has never been beaten. Nearly 2 decades later, it still stands. Engineers were shocked because there's a hard physical wall at these speeds, the pantograph whipping against the overhead wire, the wheels battling adhesion and heat. The V150 pushed right up against that wall and proved conventional rail could reach speeds people thought belonged only to aircraft. Number 1. SCMaglev L0 Series. And now, the machine that opened this video. The fastest rail vehicle ever built by human hands. It's the L0 Series, a superconducting maglev, or SCMaglev, developed by Central Japan Railway Company, JR Central, after 5 decades of relentless research dating back to the early 1970s. On April 21, 2015, on the 42.8-kilometer Yamanashi Maglev test line, a manned L0 Series train set reached an almost unbelievable 603 kilometers per hour, 375 miles per hour. It broke the previous maglev record of 581 kilometers per hour, set by Japan's earlier MLX-01 back in 2003. and it stands today as the absolute world speed record for any rail vehicle of any kind, anywhere. 603 kilometers per hour is faster than the takeoff speed of a Boeing 747. During the record run, the train held that speed for over 10 seconds with crew aboard. The technology is where it gets truly wild. Unlike the Shanghai Maglev, which uses attractive electromagnets, the L0 uses electrodynamic suspension with superconducting magnets, cooled to near absolute zero, mounted on the train's bogies. As the train moves, these magnets interact with coils in the guideway walls to lift it about 10 centimeters off the track and hurl it forward. At those temperatures, the magnets carry current with essentially zero electrical resistance. The train is, in a very real sense, gliding on a cushion of superconductivity. This isn't just a test toy either. The L0 is being built for the Chuo Shinkansen, a new maglev line intended to connect Tokyo and Nagoya in around 40 minutes, and eventually Tokyo to Osaka in about an hour. Commercial service will operate at around 500 kilometers per hour, still faster than any passenger train has ever run in scheduled service. The project has faced major delays, with tunneling disputes pushing the opening well into the 2030s, but the engineering itself is proven. Engineers were shocked because the L0 didn't just edge past the old record. It demonstrated that ground transportation could genuinely rival short-haul flight, running silently, frictionlessly, at speeds that seemed impossible a generation ago. It is, without exaggeration, the closest thing we have to a train that flies. So here's my question for you. Which one of these blew your mind the most? The self-charging freight beast, the record that stood for nearly 20 years, or the train that flies? Drop it in the comments. If you made it this far, subscribe, because the future of transport is only getting stranger.